Hello, Addy. Welcome to your lesson. Today's lesson is number 64, okay? And so the first thing that we're going to do is go over your mixed numbers that you need to write as improper fractions, okay? There's 24 of them. So get that out and get a pencil. And I'm going to start a timer for you. You're going to have 5 minutes to do it. On your mark, get set, go. I'm going to put on some relaxing music for you. That's about a minute. Keep going. You're doing awesome. That's about 3 minutes. Addy, you're doing great. Keep going. That's about 4 minutes, Addy. Keep going. You got this. All right, we're going to stop it right there. So even if you didn't finish, don't worry about it. That's no big deal. You're getting better every time, so good job. Okay, let's go right into this lesson. Today's lesson is about classifying quadrilaterals. There are lots of different types of quadrilaterals, and so we're going to learn how to classify them. So first of all, I thought you'd appreciate this little joke that is seen on a sign on the veterinary clinic. What do you call a dog magician? A labracadabrador. Can you even say that word? I had to practice the word. A labracadabrador. Okay, that's a good one. All righty, Addy. Let's jump into mental math. Do you remember this? I Love Lucy. We just watched this one the other day where she was hiding all their new living room furniture in their kitchen. And so when Ricky asked for butter on his bread and she had to go get it, she's like, butter on bread? Like, that's a really weird thing. Remember that? That was hilarious. Okay, for the first part of mental math, I'm going to get her out of the way because she's a little distracting, at least for me. We're going to count up and down by 25s, okay? So all the way from 25 to 300. And we're going to go up and we're going to go down, okay? Ready? Here we go. 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, 275, and 300. Now we're going to go backwards. 300, 275, 250, 225, 200, 175, 150, 125, 100, 75, 50, 25, and I guess 0 if you want to go all the way to 0. All right, cool. Now these problems you're going to just do in your head if you can. I've got some really satisfying videos for you to watch while you do them. We're going to do 5 times 240. Write your answer. Okay, how about 4,500, or I should say 4,500 plus 450. Okay, how would you do that? Write your answer. We did that one time with popsicle sticks. Remember when we did that? We didn't put them in that cool pattern though. All right, let's do 7 times 34. Write your answer. Okay, how about $7.50 plus $7.50? So we're basically doubling that. I don't know what this picture is of, but it kind of looks like silk. Something smooth and silky to me. Okay, and this picture I just thought was funny. It just made me laugh, so I thought you'd like it. Okay, what is 1/4 of $20? 1/4 of $20. How would you do that? If it were me, I'd probably do half of $20, and then I know that a fourth is a half of a half. So I would do this by half, and then whatever I get, do that by half. Okay, let's go to F. F is $75 divided by 10. So if you had $75 in the decimals here, and you had to divide it up among 10 friends, how much would each friend get? Okay, how about G? G is the long one. We're going to start with the number 6 times 8. That's our starting point. Now, divide by 2. Add 1. Divide by 5. Subtract 1. Multiply by 4. And divide by 2. And then for H, it basically says to hold your hands 1 foot apart. Okay, so this is going to be a foot between your hands. And then you're going to hold them a yard apart. Is that going to be bigger or smaller? It's going to be 3 times as big. There are 3 feet in a yard. Okay, so try that. All right, let's jump to problem solving. Remember on this I Love Lucy, this was a big problem for them. They broke each other's TV and then they went to court. Remember that? That's a big problem. This problem will not be as bad as that problem. So what we're going to do for problem solving is it reminds us that a dot cube has 6 faces, which we already know. 1, 2, 3, and then there's 3 we can't see. Now, where 2 faces meet, that's called an edge. We already know that. There's an edge there, there's an edge there. And then when there's a corner, that means 3 edges meet, and that's called a vertex. And you've already learned that word, I think. Vertex. The plural of that is vertices. And you spell that V-E-R-T-I-C-E-S, vertices. Okay, so they want to know a dot cube has how many vertices? So if you had to count them, how many vertices does it have? Okay, I'll let you work on that for a minute, and I'm going to go on to the new concept, okay? New concept. Why not? Here we are. All right, now we learned in lesson 60 the definition of a quadrilateral. And I'm going to review the definition of a quadrilateral. Quadrilaterals are polygons with 4 sides. So as long as it has 4 sides, it's going to be a quadrilateral. So there's a quadrilateral. There's a quadrilateral. Whoops, it didn't correct that one for me. Sometimes I like it when it does that. How about that? There's a quadrilateral. Sure, why not? Okay, how about this one? Quadrilateral. Didn't correct it for me, but that's okay. It's still pretty, even if it doesn't do that. Now, so a quadrilateral is a polygon with 4 sides. That's all it has to have. It can look like any of these, and it's a quadrilateral. Now, there are further ways that you can classify a quadrilateral. Now, you are used to doing this because you did this with your stuffed animals, right? You divide it into genus and species and all these, and order, class, family. This is kind of like the same thing, but with shapes. So the biggest definition is the quadrilateral. That's the biggest one. It's just a polygon with 4 sides. Okay, and now you can break that down further into all these other things, and we're going to start learning some of them, okay? The first one we're going to learn is a trapezium. A trapezium means that there are no parallel sides. And you remember what parallel means. It means like 2 lines that are exactly like that, like an equal sign, and they will never meet, even though they go off forever in the same direction. They are never going to meet each other, which is a shame. It's kind of sad. Okay, so but this shape right here is an example of a trapezium. See that? This is a trapezium. And if I look at the edges, I can see that there are no parallel lines, right? Because this goes off like this and this goes like this. Those are not parallel. They will meet at some point. Now this goes off like this and this goes off like this. Those are not parallel. They're going to meet probably up there somewhere, okay? So no sides are parallel. It's a trapezium. Okay, now let's move on from there. From there, we go to the next one, which is a trapezoid. A trapezoid has 1 pair of parallel sides. So out of the 4 sides, 2 of them are going to be parallel. So I want you to look closely at this picture right here. It's the blue one. It's a trapezoid. And which sides are parallel? Okay, I think you know. I think you know how to tell. These are not parallel because they are going to intersect way down there. But these are parallel. This is parallel to this. They will never meet. They're exactly parallel. So if you have 1 pair of parallel sides, then you're a trapezoid. If you have no parallel sides, you're up here, you're a trapezium. Okay? Now, let's do the next one. What if you have two pairs of parallel sides? Two pairs of parallel sides is a parallelogram. A parallelogram means these lines, let me show you. These lines are parallel, this one and this one, and these lines are parallel. Whoops, I didn't draw it very good, but this one and this one are parallel. And it kind of makes like a tic-tac-toe. And when it makes that shape in the middle, that's called a parallelogram. And it has...
lesson.
Huh? What?
I said cool lesson.
Cool lesson. This is Addie's lesson for tomorrow. Hi, future Addie. Okay, so this shape is a parallelogram. Okay, you've made it this far. We're going to take a little break and look at this joke. Okay, this guy is saying... I got a telegram. And this guy is saying, mine is a quadrilateral with parallel opposite sides. I got a parallelogram. Got it? So this guy got a telegram, and this guy got a parallelogram. Yeah, so a parallelogram is a quadrilateral with opposite sides that are parallel and congruent. Oh, I didn't go over congruent. But let me just add that since they mentioned it. Since they mentioned congruent, what it means is that this side, if you measure it, it measures the same as this side. And this side, if you measure it, it measures the same as this side, which is super interesting. There's one more thing that is congruent about this, and it's going to be these angles. So that angle is going to be the same as this angle. And this angle is going to be the same as this angle. So that is very interesting. So that's a parallelogram. Pretty cool shape. Okay, so let's go on to the next one. The next one is also a parallelogram, but it has something special. All the sides are congruent. And that's called a rhombus, when all the sides are congruent. So when all the sides are congruent, that means this measures the same as this, and they also measure the same as this and measure the same as this. It's kind of like a square, but it's tilted sideways. It's kind of like a leaning tower of squares. But that's a rhombus, okay? So it's a parallelogram with all the sides congruent. I'm going to put all the sides so we remember that. Okay, the next one is also a parallelogram, but it is a special type called a rectangle. Now you know a rectangle and you know what it looks like. And the cool thing about rectangles is that this side is parallel to this side and this side is parallel to this side. Okay? And these sides are congruent, so they have the same length. And these sides are congruent, so they have the same length. And all the angles are right angles. So it has right angles. It's a parallelogram with right angles. So if it's like you take this one, you take the parallelogram and you make it stand upright. And when you make it stand upright, it turns it into a rectangle. Okay. Now, one last one to go over, and that is the square. So the square, you already know what that is, but to define it mathematically, it's basically a rectangle with all congruent sides. So this measures the same as this, it measures the same as this, it measures the same as this. And actually all their angles are congruent too, because it has right angles in all of its corners. So a rectangle with congruent sides. It's kind of built into the definition that it has right angles because the right angles is up there mentioned in parallelogram with right angles. That's a rectangle. Okay, cool. So something to remember here because they're going to ask about this. They want you to notice that squares, rectangles, and rhombuses are all types of parallelograms. And that a square is a type of a rectangle. And it's also a type of a rhombus because it's just a rhombus that you stood up. Okay? All right, so that makes it a little tricky. So I put this, this is not in your handout, but I think it makes it a little easier to see what's going on because it's a little hard to follow all that. So let's just go through it really quick. So way up here, you've got your quadrilaterals, okay? And quadrilateral, remember, is just any shape with 4 sides. So that means that any of these, the trapezoid, the parallelogram, the rhombus, the rectangle, the squares, a kite, which we didn't go over, but it looks like a kite. Those are all types of quadrilaterals because the quadrilateral just means it has 4 sides. Okay? Now, if you are a quadrilateral, you're either going to be a trapezoid, or you're going to be a parallelogram, or you're going to be a kite. You're going to be one of those things. If you're a quadrilateral, you've got to go down one of these pathways. Okay? So the trapezoid is all by itself over here. And that's the one with no parallel sides. Now these kind of, wait, a trapezium has no parallel sides. We need to put that in there somewhere. We need to put actually this one is, the kite is the trapezium. You know what, I'm gonna call, instead of kite, I'm gonna call this trapezium because it fits the definition of the trapezium because it has no parallel sides. That's not parallel to that. That is not parallel to that. Okay, so that's the trapezium. Now, if you make 2 of those sides parallel, then you have the trapezoid. Okay, that's more like it. That makes sense to me now. So this is going to be parallel to this. Trapezoid. Okay. Now, if you have more than 2 parallel sides, you're going to follow this way to the parallelogram island. This is the parallelogram island. So you can live there if you have 2 parallel sides, like 2 pairs of parallel sides. So that means that this is parallel to this, and this is parallel to this. So that's a parallelogram. Now, that's true of all of these, right? Because a rectangle does have 2 pairs of parallel sides, just like the parallelogram, right? So that counts as a parallelogram. What about the rhombus? Yeah, it has 2 pairs of parallel sides. The only difference with the rhombus is that the sides are congruent, right? That means they measure the same length. So this is the same as this. And that's true of the rectangle too, but these have all of the sides congruent. So it's kind of like a square just tilted. A square also has 2 sets of parallel sides. This, and this. But also all of its angles are congruent and the sides are congruent. So it's interesting because if you are a square, that means you're also a rectangle. A square is a type of rectangle. A square is also a type of rhombus. A rhombus is a type of parallelogram, but a rhombus is not a rectangle. See, there's not a line there, they're not touching. But if there is a line and the lines are touching, then this is one of these. Okay? So that's pretty cool. That is pretty cool. Alrighty, so let's go on with your homework. If the first example 1, it says, is the following statement true or false? All parallelograms are rectangles. Well, let's see. Let's look at this. This is parallelogram island. I'm going to draw a parallelogram island. Everyone wants to live on parallelogram island. Maybe there's like a beautiful palm tree. Let's make a palm tree. Okay. All parallelograms are rectangles. No, that's not true because you can be a parallelogram and be a rhombus, and you could also be a parallelogram and be a square. Now, a square is a type of rectangle, but a rhombus is not. So, I'm going to say that this is false because a rectangle is a special type of parallelogram, but some parallelograms are not rectangles. And since not all parallelograms are rectangles, that means the statement is false. All right, let's do example 2. Example 2 gives us some instructions. It says, draw a pair of parallel lines. All right, so let me do that. I'm going to start with that. Draw a pair of parallel lines. Here's a line. Here's another line. Okay, they're parallel. Now it says, draw another pair of parallel lines so that the lines are not perpendicular to the first pair. What's the shape made? Okay, so they want another set of parallel lines. So I'm going to draw it not over it first, just to show you. Okay, so let's say those are parallel. And then it wants me to put it over the first set of parallel lines. But I can't put it like that. I can't put it perpendicular. That's what perpendicular means. So instead of like that, I'm going to put it like that. But you could put it any way like this. Maybe I'll do that. That's kind of cool. That's a cool shape. So then it wants to know, what is the shape that you just made? So what is this shape? Okay, so what do you think it is? I mean, you could say it's a quadrilateral. Okay. But you could also say it's something else, right? How do you spell it? Quadrilateral. But what type of quadrilateral? And I think you can see it's a parallelogram. Because if it's the definition, whoops, sorry about my bad handwriting. If it's the definition of a parallelogram because it has two sets of parallel lines. These are parallel and these are parallel. Okay, cool. And that's a lot to remember. So don't worry if you forget some of these things. You can always go back and look at those diagrams because I know that's a lot to remember. But even if you forget, at least you won't turn out with really frizzy Orphan Annie hair like Lucy. Remember that episode? That was hilarious. All right, Addie, good luck with your math today. Have a great day. Love ya. Bye.